Hello, good morning children. As I promised you that I will teach you electrochemistry from the starting. So I am going to start electrochemistry. Listen to me very carefully. So what is electrochemistry? Electrochemistry is basically the branch of physical chemistry which deals with the interconversion of chemical energy into electrical energy. Okay. So it is simply what? It is simply interconversion of chemical energy and electrical energy. Okay. Now another term comes electrolytes. What are electrolytes? You have already heard about the term electrolytes. Electrolytes are all acids, bases and salts which conducts electric current or which conducts electricity. Okay. Now electrolytes are of two types: strong electrolyte and weak electrolyte. Those are strong electrolyte which undergoes dissociation, full dissociation. Weak electrolytes undergoes partial dissociation. That means there is degree of dissociation is there. Okay. Now comes in electrochemistry another term which is very important, that is known as conductor. Which one? Conductor. What are conductors? Conductors are basically those substances which conducts electricity, and it is of again two types. Okay, one is metallic conductor and another one is electrolytic conductor. One is metallic, another one is electrolytic conductor. Okay, so now listen, what are metallic conductor? In metallic conductor, current flows due to movement of free electrons. This is very important. Movement of free electron results current flow in metallic conductor. For example, graphite. As you are very well aware that graphite is having sp2 hybridized carbon and one electron is free, which is responsible for the conduction of electricity. So this is an example of metallic conductor. Okay. Now see, what are electrolytic conductor basically? In electrolytic conductors, the movement of free ion is responsible for the conduction of electricity. Okay. Here you have to know this is due to the movement of free ions. For example, you can say NaCl, okay, which gives Na plus and Cl minus ions. Okay. Now, in metallic conductor, if you increase temperature, then resistance will also increase and conductance will get decrease. Okay. But in electrolytic conductor, if you increase temperature, then resistance will decrease and conductance will increase. Okay. Number third point, which is very important, is metallic conductor do not follow Faraday law. Later on I will tell you what is Faraday law. Metallic conductor do not follow what? Faraday law. Okay. But electrolytic conductor follow Faraday law. In this chapter basically first we will study about the electrolytic conductor, in which conduction of electric current is due to the movement of free ions. Okay, first of all we will discuss or we will study this only. Okay, this is all about what is electrochemistry, what are electrolytes, what are metallic conductor and electrolytic conductor. Okay, now comes very important one, which is conductance terms. Okay, what are conductance terms? देखिए इलेक्ट्रोकेमिस्ट्री में दिस इज वेरी इंपॉर्टेंट टू नो अबाउट द कंडक्टेंस टर्म, बिकॉज वी आर डीलिंग विद द interconversion of chemical energy into electrical energy, and if we are dealing with electrolytic conductor, then we have to understand some conductance terms. Okay, so let's start first conductance term, which is conductance. Simple conductance, it is denoted by C or denoted by capital G. Okay, it is simply denoted by C or capital G. So conductance, simple conductance is what? 1 upon resistance. Okay, so and the unit will be what? 1 upon resistance, that means ohm. The unit for resistance is ohm, so it will be obviously ohm inverse. Ohm inverse is also known as MHO, which is mho, or you can say Simon. So the unit for conductance is ohm inverse, MHO and Simon. Please mind it. Okay, next conductance term is specific conductance or conductivity. Please note, this is very important. Sometimes we used to say specific conductance or conductivity. It is denoted by kappa. What? Kappa. See how this is different from simple K. This is kappa. Okay. So what is kappa basically? See, if resistance is directly proportional to small l upon capital A. What is L here? L is what? L is the distance in between the two electrodes in centimeter. A is the cross-sectional area of the electrode. So if resistance is directly proportional to L upon A, it will be equal to R is equal to rho L by A. Rho is proportionality constant, also known as specific resistance or resistivity. Please note what is rho here. Rho is simply specific resistance or resistivity. Okay. So come to this point. Here if I do like this, 1 upon rho is equal to 1 upon R L upon A, it becomes, what is this? Specific resistance. Specific resistance. So simply it will become what? 1 upon rho will become specific conductance, that is kappa. So kappa is equal to 1 upon R L upon A. Please note this. So kappa is basically, because 1 upon R is what? Conductance. You can see. So I write conductance into L upon A. What is L upon A? L upon A is cell constant. Okay. You have to remember this point, that L upon A is what? Cell constant. So again like this we have to find out the unit for kappa, and the unit for kappa will be obviously 1 upon R becomes ohm inverse, L upon A becomes centimeter inverse. So here ohm inverse is what? MHO, and MHO centimeter inverse may be the unit, or Simon centimeter inverse may be the unit for specific conductance or conductivity. Okay. See, here occurs one case. If we want to define specific conductance, how can we define? See, if I take L is equal to 1 centimeter, what is L? Again I am repeating, L is the distance in between the two electrodes in the electrolytic cell. Okay. If that distance is what? 1 centimeter, and the cross-sectional area of the electrode is what? 1 centimeter square. So the volume becomes how much? Length into area, which becomes 1 centimeter cube of the solution, or 1 ml. Okay. So it becomes, kappa becomes 1 upon R simply, because L is 1, A is 1 centimeter square. So kappa becomes 1 upon R, which is equal to the conductance. So here it is all about a specific conductance or conductivity. Simply you can define it as, if the distance in between the electrodes is 1 centimeter and cross sectional area is 1 centimeter square, then specific conductance becomes equal to simply the conductance. Okay. Now third conductance term is equivalent conductance. Please note equivalent conductance. Lambda EQ or kappa EQ. I am sorry, lambda EQ or cap EQ. Okay. So what is equivalent conductance basically? So conductance of all the ions, see, you have to note this point, conductance of all the ions produced by 1 gram equivalent of an electrolyte in a given volume or solution is called as lambda EQ. What, again I am repeating, what is equivalent conductance? Conductance produced by 1 gram equivalent of an electrolyte in a given volume is called equivalent conductance. So please note, if conductance of 1 ml solution was how much? Kappa. You can see here, you can see conductance of 1 ml or 1 centimeter solution was how much? Kappa, from here. Okay, from this case you can see. So if 1 ml solution is having kappa, V ml solution will be having how much? Kappa into V. Okay, in next video, because I cannot make so much lengthy videos, next video I will continue from here. To be continued. Thank you.